This is part 4 of the Python crash course. In this video, I'm going to show you how to work with the NumPy. NumPy is a scientific library of the Python. And remember, your aim is to learn the neural networks. And neural networks use the pandas a lot, and the pandas in turn use the NumPy. And that's why you need to be expert of the NumPy for sure. And let me explain why you need to learn NumPy. If you go to linkedin.com, and don't look where my feed, let's search for NumPy. And let's look at the jobs. If you look at all of the like a data scientist, machine learning type of jobs, you're going to learn that they will require NumPy and SciPy type of libraries and so on too. And if this is just one of them, if you click on any of them, you're going to see NumPy somewhere in the description, okay? And let's have a look at the others too. Search for NumPy. Yep, you got the idea. And here's the idea. In part number 4, I'm going to cover the NumPy. In part number 5, I'm going to cover the pandas. And these are the building blocks for any kind of machine learning project. And specifically, you're going to learn neural networks later. But for the time being, it's quite important for you to learn the NumPy. And if you're going to be in the analytics world for the long run, it's not a problem that you're going to, like, whether you're going to learn or not, the NumPy is not a problem or any kind of question that you have. The reason is that you're going to be dealing with the NumPy in the long run for sure. And it's better for you to learn the NumPy as soon as possible. And NumPy is a scientific library for Python, and it has been around for almost 17 or 18 years. And the reason the people built the NumPy is that the Python is extremely slow programming language. And think about this way, in any kind of neural network problem, you're going to be working with like hundreds of thousands of rows and at least like 50 or 60 columns and so on. And it means that you are going to have like 1 million data points at least. Sometimes it's going to be order of billions, by the way. And in that case, the Python will not crunch the numbers quite fast. That's why people built the NumPy. And if you look at the NumPy wiki, let's have a look at it. Oh, actually, it has been around since 2006. And what people is this, there's another programming language called C. And whatever we are writing in the NumPy is going to be converted into C. And then it's going to run as a C code. But this basically is going to be abstraction on top of the C. C is a programming language developed at least 40, 50 years ago. It could be even more than that. And it's quite fast compared to Python. And the idea is this, even though we could be coding in Python, those code is actually converted to C, and the actual code is running in C, okay? But you don't need to know how the C is working fine. And C has been around for quite a long time, but it's a pretty old and difficult to learn language. NumPy is way more simple. Let's change the notebook's name to Python Crash Course. Part 4. I really hate this keyboard. Okay. And the very first thing I'm going to do is to import the NumPy. I'm just going to say import NumPy as NP, and let me explain what this means. The NumPy is not part of the Python, and when I issue import NumPy as NP, it basically means I want to use this library. Somebody wrote this library, and from now on I'm going to refer to NumPy as NP. Okay. And let's create a simple list that you have seen before. Let's give this numbers 0, 1, 2, 3, 4. Okay, this is a regular list. And let's say you want to create another NumPy array. You're going to say NP. In this case, NP is referring to NumPy. And when I put the dot over there, these are all of the functions available in the NumPy library. Actually, you don't need to know any of this. I'm just going to say I want to build a new array, I'll give the name np.array. Inside the array, I'm going to put the numbers 0, 1, 2, 3, 4. Okay. And let's assign ARR to this thing equals to this one. And the difference between the mylist and the array is this. If you look for the mylist, that's going to be in the list format. If you look at the array, it's going to say array 0, 1, 2, 3, 4. Basically means this: whenever we want to do some kind of calculation with the NumPy arrays, the second one, the one with the name ARR in this case, is going to be way faster compared to list. Okay, that's the reason we are using the NumPy arrays. Okay, and let's work with the NumPy arrays a little bit. And remember, this is my list. I can create another array. Let's give the name new array name. What I can do is this: I could say np array, and inside the array I can pass a list which is already exists. This is going to create a new array for me, which basically means you don't need to type the numbers one by one. If you have a list, you can convert it to an array like this. Okay. And remember, we used to have range function. Let's say range 10. This is just going to say range 10. But if I want to print those numbers, or it's going to show the numbers from 0 to 9, not including 10. And the same thing exists in the NumPy too, but the function name is np.arrange. Let's put number 10. This is going to create a NumPy array of the numbers from 0 to 9. It basically means create a NumPy arrange with 10 numbers. Okay. And just like the way that before, I can have starting position and ending position. This basically means start from number 1, go all the way to number 10, but don't include number 10. Okay. Basically means I'm going to create 9 numbers, and these are going to be part of the array. And similarly, I am not sure about this one, what we are going to see. Let's have a look at this guy. Yep. And if you have this condition, it basically means start from number 1, go all the way to number 10, don't include number 10, and increment it by 2. This is also another way of creating the arrays. And there are also special functions. Let's say np zeros 5. It basically means create an array of type 5, and every single number is going to be 0. And this part is super important. Even though I asked it to create the number zeros, it created 0 dot. It basically means these are all float values, and it basically means all the arrays that you see over here, even though they are of integer type, they are going to be considered as a float. And those zeros are going to be important later. Let's do this one, np1s. Let's say 10. Basically means create an array of size 10 with numbers 1. And let's do this one too. Sometimes you're going to be working with matrices. Okay, matrices are basically two-dimensional arrays. Let's give it a name. I'm going to create another variable called another list. I just want to remind you this thing. Let's say in my list I have numbers 1, 2, 3. I'm going to build a nested list. Let's give them 1, 2, 3, 4, 5, 6. And another list 7, 8, and 9. Okay, this is not an NumPy array, this is just a regular list. If you say another list 0, basically means you're going to go get the 1, 2, 3. The reason is this is a nested list. The one that I highlighted is the element number 0. You can convert this whole thing into an array. Okay, let me show you. Let me remove this one or move it down. What I can do is this: I can say np.array, and I can pass another list into that one. And if you look at the array right now, this is a little bit different. Not everything is just like a one row. It's in 3 different rows. The reason is this is right now is 3 by 3. And the idea is this: if you happen to give a nested list, it's going to take the rows like this one. And if you look at the array definition here, it starts with 2 brackets. It basically means this is 2-dimensional. Okay, let's give it a name, new array, equal to this thing. And if you look at the new array, that's what you're going to see. Okay, and let me explain how we are going to access the elements of this array. If you say new array 1, okay, it basically means it's going to go get the row number 1. And remember, 1, 2, 3 is the row number 0, 4, 5, 6 is row number 2. That's the way that you're going to access the rows. If you say, let's do this one, new array 1 and 2, you're going to go get the number 6. Here's what it means. Go have a look at the row number 1, which is 4, 5, 6. Of this row, go get the element number 2. And remember, 4 is element number 0, 5 is element number 1, 6 is element number 2. That's why I'm going to end up with 2. Okay? You could also do this one, even though I don't like it at all. You can say 1, 2. I put a comma between. It's going to return to number 6. It basically means go get the row number 1, and in the row number 1, go get the column number 2. Okay? And the reason that you're learning this stuff is this, like in neural networks, in the future, you may be working with like image processing, and every image, there will be tons of pixels, and every pixel have 3 different colors. It will be 3-dimensional. And NumPys are basically dealing with multidimensional column, multidimensional data. That's why I'm showing you this material right now. And there's another function that I want you to remember, and that one is called I. And this is the same thing with the identity matrix. Let's put number 5 over there. It means create a 5 by 5 matrix, and the diagonals are going to be number 1s, or other are 0. NumPys are excellent for linear algebra, and whenever we are dealing with neural networks, basically means we are dealing with the linear algebra. And remember, you also learn linear programming in this course. Linear programming is actually based on the linear algebra too. Think about all the constraints that you have. You can write your constraints in a 2-dimensional array like this one. It's basically doing those calculations on its own. Okay, and you need to remember those functions very well. And another function that we are going to might be using is random. Let's go, and this basically means go to the random, go to the NumPy, and then go to the random library inside the NumPy, and use the random function. Let me show you what it does. This guy is going to return a number between 0 and. This is from a uniform distribution that you learned before. And if you enter some number inside, let's do it. It basically means create an array of size 10, and every single element or number inside this array is going to be between 0 and 1, and they're going to be random. And the numbers that you get could be different because of the different random seeds and so on, but you should end up with 10 numbers. And pay attention to the details. This array right now that you see is 1-dimensional. The reason is this: look at this part, there's only one bracket. It means it's 1-dimensional. Even though it shows up the values in 2 rows, this is just a 1-row array. Okay, and look at this one, it is 2-row arrays because it starts with 2. And look at the np.i5, this is 2-dimensional. Okay, at any time, if you want to understand the number of dimensions in the array, let's give this a name A. You just type a.shape. Tells you this is just 1-dimensional. There's only 10 rows in it. But if you look at the np.i, let me type np.i, let's say 7.shape, and this is a property, not a function. Okay, that's why I'm not putting a parenthesis here. You're going to see 7 by 7 is 2-dimensional. Okay, and the reason it's going to be important is this: sometimes you're going to be working with multidimensional arrays, especially with the neural networks, and you have to provide the correct dimensions to the neural networks, and this is the way that you're going to check it out. And remember this: Everything that you're going to be working with the neural networks depends on the pandas. Pandas in return is written on top of the NumPy, which means that anything that you learn in NumPy applies to every single thing in the neural networks. Okay, and let's have a look at, and by the way, if you go to Google and then search for numpy.random, okay, you're going to see lots of different functions over there. If I were you, instead of watching the Netflix videos, I'll go to NumPy, click on the user guide, and start reading the material over there. You may not remember the stuff very well, but as long as you will remember those things exist, you should be able to find it out over here. And the website is numpy.org, and it will give you an idea about what NumPys are and so on. Let's have a look at the NumPy random. I will go back. Let's have a look at the NumPy random functions. Okay, I used to know them very well. Let's have a look at it. Let's go to random generator. Inside the random generator, you're going to see tons of different function names. Remember, you learned the exponential distribution. That's the way to create you can read the description over there. And if you scroll down, you look at this np.random.default RNG exponential. This is the way to create the exponential random variables. Or you already learned let me have a look at it, binomial. Okay, that's the way to deal with the binomial. This is going to create this function that you see here, np.random. Actually, this is going to be np.random.default RNG, and then binomial np1000 is going to be the way to create the binomial variables and so on. Okay, I'm not going to go over every single like a function here, but this is the way that you're going to work with them. Okay, let's go back. And I'm going to give you more information about some of the common ones that we use. np_random.randn is going to return a random variable with mean 0 and standard deviation 1. And n over here is simply the last n that you see that I just highlighted is just for normal distribution. And sometimes you want to, for example, if you just put number 10 inside, it's just going to create an array of 10 values. Each of those numbers are going to be from a standard normal distribution with mean 0 and variance 1. And there's another one, np.random.randint. Okay, look at the description that you see. And right now, the Python notebook is trying to help me out because this function is not used a lot. It's giving me all the way to the top. You see the low, high, and the none kind of values. It basically means, look at the description. It says return random integers from low inclusive to high exclusive. It basically means I need to provide the low value and the high value. Let's say I want a number between 0 and 100. This is going to be creating a random integers. And let's do it. Okay, and remember 100 is going to be exclusive. Let's say I put number 7 over there. This basically means create 7 numbers between 0 and 100, and each number over there is going to be equal likely. Okay, and I'm going to be using the random number generator to populate some of the pandas and so on. And this is why I'm going over the random numbers. And the other thing is this. So right now you're already expert in Python, and Python is going to be part of the Excel later. Basically means by using learning the Python, you should be able to use new functions which were not actually part of the Excel. You can write your own functions. You can use any function that's already inside the NumPy, and you can use them in Excel. That will be excellent for you in the long run. What I mean is that you can solve lots of problems by accessing the Python inside the Excel. Okay, and the other function that I wanted to know is the reshape. And remember, let's say we have an array. Did I create the array? Okay, let's say I have this array, and inside this array, I have, actually only 5. Let's create another array. I'm going to say array equals np. Let's go use random int, np.random.randint. Let's say I told you, create numbers between 0 and 100, and let's create 25 numbers. Let's create 30 numbers. Okay. And it basically means from now on, array is going to be this whole thing. And if you look at the shape property, you're going to see it's going to 30 by nothing. Basically means this is one dimensional and I have 30 numbers over there. And I can use the reshape function. And reshape is just going to convert this one into another format that you're looking for. Let's make this one 5 by 6. Basically means make this one 5 rows, 6 columns. That's what it means. And keep this in mind, this is not going to change the original array, okay? Original array the same, it's just going to be creating a new array for me, okay? And there are also other functions that you should know. Remember the maximum is going to return the maximum value inside this array. Similarly, min is going to return the minimum value. And if you go to NumPy and then look at the user guide, you can see all the available functions over there. I strongly recommend you to go to tutorials and then read those stuff over there, okay? And there are also one function that I want you to know very well. Let's give the name argmax and let me explain what it means. And remember, the maximum value inside my array is 99. This basically means show me the position of the maximum value. And remember, this is my array. 54 is at position 0, 68 is position number 1, and it goes on like this. Look at the 99. This is in position number 4. That's just telling me where it is. Okay. Same thing for argmin. This is going to show me the position of the minimum value. Okay. And probably this is the one over here, right? If you can't, it's going to be the element number 8. Okay. And the indexing is quite similar. For example, if you say array 4, you're going to go get the, this is the maximum value, array 4. Let's look for the 7, it's going to get the minimum value, okay? And slicing is exactly the same. If you say array 3, nothing, colon, and 3 basically means go get the first 3 elements. And if you say array, let's do this one, 5 to, basically means start from element position 5, go all the way to the end. If you have something like 10 to 15, means go get the element from 10 to 14, okay? And you can also do this one. Let's do this one, slice of an array. You can do this one, array 10 to 11 or 15. Basically means I created another array. If you look at the slice of an array, you're going to go get these numbers. And you have to be quite careful whenever you are slicing the arrays. And let me explain why. Let's have a look at the slice of an array one more time. If I do this way, it basically means go show me all of the elements. Let's say I want to change those values to 100, okay? And here's what happened. If you look at the slice of an array right now, all of the elements are going to be 100. But here's the important thing. Remember the original array? Let's have a look at the original array. You see those values, 100 and 100 all the time. The issue is this. And keep this in mind, and NumPy are just optimized for the computer's memory. And whenever you are slicing an array, you're actually getting a reference to the you are getting a reference to the array. It basically means slice of an array refers to the numbers that I'm highlighting right now. If you change the slice of an array, the original array that you make the copy will also change at the same time. Okay, you have to be super careful. What I mean is this. And if you want to copy the elements, this is what you're going to do. You're just going to say array copy. Let's give this a name, new array. And right now, this is just going, new array is going to be copy of the original one. Okay. If I change the values inside this array to 200, okay, the new array is going to have only 200s, but the original array will not change, okay? Which means that if you want to create a copy and then make change over there, you need to use the copy function like the way I have shown you. If you only get the slice of an array and then make change, the original array is going to be updated at the same time, okay? Don't forget this. And I already explained you the multidimensional arrays. Okay, let's have a look at the array that we have. If you have, let's say you want to find all the numbers greater than 20 inside this array, this is what we're going to do. This is going to return a Boolean array. Basically means that, remember, if you happen to do the same thing to a list, let's do it, it's going to give you an error. Remember all the way to the beginning, I created the my list. If I say my list greater than 20, this is going to give me an error because it's a list, but you could do this stuff in arrays, which makes it easier to work with the arrays. Okay, and you don't need to write like a for loops and just iterate through all the array elements and so on. This will be way more simpler to work with. Okay, and let's continue. And remember, I got the true and false values here. Let's say I told you, show me all of the elements greater than 20 inside the array. And let's do this one. Let's create another array called Boolean array. And I will say array greater than 20. This is going to have true and false values. Let's have a look at the Boolean array. Okay. And remember, this is my original array. I have only numbers. And this part is going to be a little bit difficult to grasp first. But if you say array inside the brackets, if I pass bool array to this guy, here's what is going to happen. And remember, my Boolean array is true and falses. It basically means if it is true, it's going to show up this number. If it is false, let's find one false. It's not going to show that number at all. Okay. And if you look at the new array, you're only going to see numbers greater than 20. And this makes the life is way more easier for us. Okay. Actually, I even don't need to do this one this way. I can do it this way. Array greater than 20. This will also solve the problem. This is just going to give me all of the numbers that are greater than 20 in the array. And this is just what makes a NumPy is super powerful. I don't need to write for loops, and I could get this one quite fast. And remember, everything that you see over here is just a one layer, like a abstraction. Everything is running in C. Everything is super fast. Right now, I'm only dealing with 20 to 25 numbers. You won't see the difference in the pace. But sometimes I'm going to have 3 million different numbers. And if I happen to have things in the list, it might take like 2 or 3 minutes to get the calculation done. But if I have the stuff in arrays, in NumPy arrays actually, the thing is going to be calculated in 3 seconds. Okay, that's how much difference it's going to make. That's why people are looking for, or the companies are looking for people who are going to be working with the NumPy. Okay, because it's going to save them lots of time. Okay, think about Facebook. They have billions of users. They could be making predictions about those users, and everything is based on the NumPy. The stuff is going to be calculated quite fast. Okay, and let's have a look at this guy. You can do simple calculations like this. Basically means it's going to go find out the first element. Okay, let's have a look at the original array one more time. This is the original array. I have 54. It basically means first element is 54. It's going to find, it's going to basically 54 plus 54. That's why I got 108 over there. Okay. The second element is 68. It basically means 68 plus 68. That's what I got the number. Which means that I don't need the for loop. I don't need to iterate. You could just use the NumPy arrays. Okay. Same thing for the subtraction operation. Okay. And I can even go ahead and multiply the array by itself. Okay, this is going to be basically 54 multiplied by 54 and so on. You get the idea. Okay, let me separate it so that it will be easier to read. I can even add scalars to these things. Let's say I add 100 numbers, 100 to every single element. And I can even multiply arrays, let's say by 5. Okay, it's that much. And remember, you have to be super careful whenever you're working with the arrays. Remember, let's say I want to do this operation in Python, 1 divided by 0. Since this is going to be division by 0, it's going to give me an error. But you could do this one. Array divided by array. Let's run it. Okay, that's what I'm going to get the ones all the time. But let's have a look at the array 0, the first element. This was 54, right? Let's make this one 0. I'm going to show you the division by 0. And let's have a look at the array one more time. Perfect. And pay attention to details. If I have array divided by array, this basically means I'm having an operation 0 divided by 0. Okay. And this is going to give me an error. Actually, it's not going to give me an error. This is called basically a runtime warning. And whenever you see these letters, NaN, is basically the Python's way of saying this thing cannot be calculated. Okay. Same thing here. I have another NaN. It basically means I'm dividing 0 by 0. It's giving me an error. And the idea here is this. Even though this is like a operation that I should have been doing, sometimes this is going to happen and those values are going to be replaced with NaN, but the calculation will be done and I could continue running the code. Okay. And there are also other functions that you should be familiar with. NP that we might use later, square root. If I pass the array here, it's going to find out the square root of all those numbers. And exp is the exponent of those numbers. Okay. And what else? And what I recommend to you is basically go to numpy.org and instead of wasting your time watching those Netflix videos, make sure that you look at the tutorials over here and then watch them. As I move forward, I'm going to probably introduce more things about the NumPy errors, but these are the things that comes into my mind right now. And this is part number 4. And you just learned the basics of the NumPy. And keep this in mind, like I already told you about this one. If you're in data analytics, you have to be an expert in the NumPy. And you can't run away from this. And I strongly recommend that you learn Python NumPys as soon as possible. Okay. And the next video, I'm going to go over the pandas and I'm going to explain this material in detail over there too. Okay. Thank you. Have a great day. Bye-bye.